Most modern AI products looks different on the surface. Different apps, different demos, and different buzzwords. But under the hood, they are built on the same core ideas. In this video, I will walk you through 9 core concepts you will see again and again in real-world AI systems. So once you understand these patterns, AI stop feeling mysterious and start feeling engineered. Concept 1. Tokenization. So AI model don't understand text the way humans do. They can't read words directly. So we translate language into numbers. A tokenizer breaks text into small pieces called tokens and maps each tokens to an integer ID. The most common method is byte pair encoding, BPE. It starts with small units like characters and repeatedly merges the most frequent pairs. And that's why walking often becomes walk plus in. And from here on, everything becomes math. And the second concept, we have text decoding. An LLM does not write sentence, it predicts the next token. At every steps, the model outputs a probability distribution over all possible tokens. A decision strategy then chooses one token, adds it to the sequence and repeat the process. Greedy decoding always picks the most likely option, reliable but often boring. And sampling methods introduce controlled randomness. And that's how you get creativity and variation. And the next concept, we have prompt engineering. So prompt engineering is the art of giving clear instruction without changing the model itself. A strong prompt defines the task, the concentrate, and the expected output format. A few short prompting shows examples, chain of thought prompting, encourage step-by-step reasoning. It's popular because it's fast, flexible, and far cheaper than training a new model. Concept 4. Multi-step AI agents. So on its own, an LLM only generates text. It cannot browse the web, run code, or take actions. So agents change that. They wrap the model in a loop, they plan it, use tools, observe results, and decide the next step. And this cycles repeats until a goal is reached or no further progress is possible. And that's how AI systems actually do things. Concept 5. Retrieval-Augmented Generation RAG. A plain LLM answer using only what stored in its weights. And that means it can be outdated or wrong. So RAG connects the model to external knowledge. First, relevant documents are retrieved from PDF, databases, or any internal documents. Then the model generates an answer grounded in those sources, and this is how you build AI system you can actually trust. So the next concept, we have reinforcement learning from human feedback, commonly known as RLHF. So early language models predict text well, but were not very helpful. So RLHF changed that. The model generates multiple responses, humans rank them, a reward model learns those preferences, and reinforcement learning then nudges the model toward output people constantly prefer. And that's why modern AI feels aligned, not random. Concept 7, we have variation autoencoders, VAEs. A VAE is a generative model that learns a compressed representation of data. An encoder maps input into a latent space, a decoder reconstructs them, and after training, you can sample the latent space to generate a new data. So in modern image and video systems, VAE act as efficient latent compressors. And the next concept, we have diffusion models. So diffusion models learn by adding noise. During training, noise is gradually added to a real data, and the model learns how to remove it. At inference time, the process runs in reverse, starting from pure noise and slowly forming a clean sample. And that's how many state-of-the-art image and video generation works today. And the next and final concept, we have low rank adoption, commonly known as a LoRa. So large models are generalized, but real world problems are specialized, right? So LoRa fine-tunes models efficiently without updating all their parameters. So it keeps the original weights frozen and adds small trainable low rank metrics. And the result, lower cost, faster training, and domain specific intelligence. So in closing, I would say AI is not a magic, it's architecture. So once you understand these building blocks, reading AI papers, products, and system designs become much easier. So you stop asking, what model is this, and start asking, how is this system built? And that's when AI become understandable and buildable. My name is Martin Christie. I'm freelance data and AI consultant based in Copenhagen, Denmark, focused on AI architecture, inference system, automation, and real-world deployment. So I help companies move from AI experiment to reliable, compliant system that delivers real AI values. With a strong focus on EU sovereign, GDPR-aligned AI adoption across the Nordics, and if you need any help or support in AI adoption, architecture decisions, inference performance, or compliant AI system in Europe, feel free to reach out to me. I am always happy to help and support.